Okay, hello everyone. Welcome to MakeNet Hacks tutorial for week 6 in natural language processing. Our two mentors, Sami and Elaine, will go over the assignment that they've prepared. The assignment can be found on the Google Drive link inside the Gumroad platform that we have, where all of the material of this course is there. So Sami and Elaine, make sure to introduce yourself when you start the tutorial. Give like a brief overview of your professional interests, like your career interests, and take it away. So I'm gonna allow for screen sharing as well, and the floor is yours, Sami.
Okay, I'm gonna share my screen. Okay, so my name is Sami Bahig. I'm a data scientist. I have studied my data science and artificial intelligence in MILA. So I'm postgraduate. I'm also by training, I studied medicine and pharmacology. And so, and I'm actually doing research in medical image detection of cancer in Seattle, Montreal. Do you hear me?
Yes, we hear you, but we don't see your slide.
Okay.
Slideshow. We see your slides. It's your regular window, not the slideshow. Now we see the slideshow. Yeah.
Okay, excellent. So I introduce myself. I'm going to go fastly through some basic concept of NLP because last Saturday he went very fastly through NLP. I think NLP is a very big topic. Honestly, even in 40 hours, you can just have a shadow overview of it. I have done many classes on it, and even though I don't consider myself expert yet, hopefully soon, but not yet. So, but I think it's important to have at least some basic concepts that maybe he forgot to go through last time. But NLP is the way to process and analyze human language data. And there's so many examples of that today. I think it's a very hot topic, like, you know, ChatGPT and you will always see like new models. But there is always like a pipelines because you want to, you don't analyze language like this, like raw language. You usually there is many things you have to do. You can choose it depending on the task. But one of the things you can do is tokenization. Like you have to break it into smaller units, such as words or subwords. I think Ellen will talk about this in details a bit later. There is also parts of speech tagging where you assign grammatical tags for each word in sentence. There is also name entity recognition where you identify and classify name entities like names, location, organization, so on. And of course, one of the typical one is a text classification where you categorize text in predefined classes or categories like sentiment analysis and topic classification. So there is also text generations like GPT-4 is a typical example. Machine translation like Google, you see like Google translation. This is automatically translating text from one language to another. And speech recognition like Siri and so on. Also speech synthesis. So it's a very hot topic. I absolutely love it, but you just need to understand some basic concepts so it will not be too much complex. There is many libraries, but I think the most important one for beginners to know, first one is NLTK. It's a widely used Python libraries for NLP task. You have all kinds of methods there, such as text processing, so on. It's very easy to install. You just need to install NLTK, and you can just check on their API the different methods. SpaCy is also one that you should be familiar with. Same as NLTK, there is a lot of methods for pre-processing. GenSim also is very interesting. Scikit-learn for the models, if you want to do some text classification with naive Bayes or non-naive Bayes methods. And of course, TensorFlow and PyTorch for deep learning models. And Hugging Face also is must known today because it's very huge libraries for transformers. They are all easy to install and even easy to use. So, but you just need to be aware that those are the most important one in the field. NLP is hard. I'm not going why it's hard. but it's human language is very complex and it's ambiguous. The syntax and grammar can be hard. There is words that are not used during training that may exist in the real world, and the context is very important. So even though the best NLP models, I'm not sure there is 100% perfection today, but they're very good. But it's, you know, that is hard. One of the basic tasks of NLP is to represent the language. Usually we represent them in form of vectors. So there is many ways of to do that. One of them is embedding, and it's giving like it's an efficient word representation that are done with deep learning models. Another one, a typical one, is bag of words. One hot encoding, I think you should know, or it's very known one. There is TF-IDF that Ellen is going to talk a bit about later. And the N-gram also is a very famous one. I'm not going to go all NLP tasks, but basically you need to know that you can do, as I told you, text classification, sentiment analysis, topic modeling, text generation, and text summarization. Also, it's a huge topic today also. Also information retrieval. Okay, I'll go through the tutorial now. I just want to make this first introduction so that we all talk the same language. And I'm going to share a very short tutorial that I already shared. Do you see it? No.
We see the code, we see the notebook.
Okay.
See, I see your browser. That's fine.
You don't see the collab? Okay, I'm gonna.
I do. Yes.
Okay. Okay, this one is Ellen's. Okay, this one is mine. This one is tutorial because I done many NLP class. I have done it in the NLP class. It's very interesting to see some very basic commands. First, just installation of libraries. In NLTK, which is a typical one, you will first need to bring a few models like before pre-processing the data. So usually you do NLTK downloads and you add the method that you want to use. So you can check on the API, and then you can make the tokenization. Tokenization is just dividing the sentence in different words. Like here, you see the sentence is full, and then you use the method word tokenize, and you have each token like this. You can try it. You should have access to this tutorial. You just have to run it. Here is an example where we use the method pause tag of NLTK. So it's just dividing the sentence in like kind of tags. Yeah. So, and then there is this method. I don't know how much time I still have, but here we're using name entities and spicy also to do the pre-processing. And then we're going to use the data set, which is EMDB data set for sentiment analysis. We're first going to get it. We're going to download it. And then we make the pre-processing in this function. It's very important. You need to clean the data. One of the most important steps is to clean the data. You have to take off the point, the punctuation, the redundant words, the stop words, and so on. This is cleaning the text is a very, very important task. But you have a lot of tools in the libraries that I told you, especially spaCy and NLTK. After that, you tokenize, but the cleaning is the first step. It's very important. And then this is here. They're just making a frequency distributions. It's like N-gram, not exactly the same, but just calculating for each word how much the word is. It can be a task that you use in some projects. Here they're taking off the stop word removal. Stemming and lemmatization is two important concepts that you need to be aware. I think Ellen, you should talk about this a bit more in data, so I'm not going to focus too much on that. But stem is like, in Latin, it's like la racine, and lemmatization, it's I know it's just like when you limitize, you just keep, for example, strips, you just keep strip of the word. So any words that will have strip as a core will be recognized as such. So and for the limit, sorry. Okay. So for example, if you limitize the word carrying, it will return care, etc., etc. This is two methods that they look a lot of the same, but it's not exactly the same. You should just read about the difference between a lamb and a stem, and you will understand. But basically, this is two methods that we use to recognize words, and especially families, all the words that are related to a word in a text. Yes, basically, I don't want to spend too much time. There is many methods of classification. One of them is naive Bayes classification. They all have different mathematical concepts, but here we're using the naive Bayes theorem. So here, after pre-processing the data and the text, we use naive Bayes method, and we arrive to accuracy, which is 79.8. Accuracy is sometimes used in NLP. Most of the times, you will not use accuracy. There is others metrics that we use in NLP, but accuracy can be used when we use a naive Bayes. This is an n-gram method. I'm not going too much into n-gram. It's a bit complex, but n-gram is, as I told you, is a way of representing data, but per group, per one word, 2 words, 3 words. So you check the words that is before and after, and you can choose the number of gram of words that are before and after, right? Yes, I think that should be okay for now. I will first take some questions, and if we have time, I'll go to some other concepts. Okay. I have questions. I have prepared questions for you. I've sent them to Hussein, and you can try to answer those questions, coding questions now if you want. And yeah, I'm sorry. Do you hear me?
Yeah, I
Yes.
hear you.
Okay. I think my challenge was to be on time. I succeeded to be on time. Maybe I hope I did not go too much fast, but I did not, because I have if there is any concept you want me to go back again or through, I can go. But I can go to the Word2Vec. Word2Vec is very interesting. You can run the code here. Word2Vec, where first here we uploading the data, and then it's just another way to make a representation. Yeah, so it's use a different algorithm to make representation of data. Yeah, so I'm done. You can just go try the question that I sent you, and ask me a question now if you want, and maybe in a few minutes, 5 minutes, Ellen could continue.
Right. So I'm not like, I don't have any like specific questions for you. Like, so at the coding questions, like would you be able to like type in the answers at the moment, like to show them type in the answers? Like, yeah.
Sure. Okay, I'm just going to bring the questions. Okay, so do you have access to the question right now?
So the one that you emailed me or the one that you shared with me?
The one that I emailed you, do you have them?
Yeah, I gotta go back to my email. Just give me a sec. So that's the text file, right?
Yes, it should be the text file, yes.
Okay. So I'm sending you these questions over chat. You can copy paste it to the Google Colab notebook that you're viewing right now,
Yes.
and then go over them. So
Oh no, this was the first question I sent you. This was the Python questions. I sent you another set of questions just after the email. After that one, please, Hussein. Sorry.
so what's the title of that one? Is it the document that you shared with me?
Yes. Okay. I'm going to. Okay. You know what? I don't want to make. Maybe go and then go ahead. I will just send the questions again. I don't want to waste too much time because it's in the second email, Hussein. If you have it, go ahead. Otherwise, maybe we can.
Yeah, it makes sense. Like Elaine, if you can come in, type in, and then we'll figure this out with Sam in the background and Sam.
Okay. Just give me a few minutes. I'm gonna send it again. No problem.
Right. Cool. So yeah,
Okay,
thank you so much, Sam.
sound-
Yeah, Elaine is yours.
Sounds good. So before I begin, I'll just give a quick introduction of myself. So I'm Elaine, and I'm currently doing my master at Mila with a focus in reinforcement learning. So I guess like probably after graduating, I'm more interested in the industry side where I am applying machine learning in real life applications. So if anyone is interested to know more, you can also like connect me on LinkedIn and we can chat from there. So I'm just gonna share my screen. Oops. Okay. So for my part of the tutorial, I will specifically focus on using count vectorizer and TF-IDF in terms of text classification tasks. So specifically, if you have any familiarity with these algorithms, actually like tokenization or any type of preprocessing can affect the performance. So this is what we'll be focusing on today is like what exactly we should do in terms of the preprocessing part to lead to a better performance. So I guess I haven't shared this data set on the Colab, but essentially it's like from the Kaggle where you just download that movie reviews. I can share the link on the chat right now. I will share my LinkedIn profile later, but so yeah, like essentially I just downloaded it, uploaded it on the notebook, and I guess I will start from the beginning to the end. So to start off, obviously you can just import the libraries, and some of you have already talked about some of these libraries. So sklearn is definitely like if you can just do things without writing things from scratch, just use like existing libraries. And in terms of NLTK, you can just like import the stop words that are more common, as well as lemmatization and stem, which we will dive more into it after, and just download packages. So yeah, like to start off with any type of specific data set, you definitely want to just look more into what the data set looks like. So for here, you see that there is like 2 columns where upon importing it, you see there is different reviews where they're also provided a sentiment, like whether it's positive or negative. And something you should be aware of in a traditional sense is that when you're looking at data sets, you should also look at the labels like a value count of it, because say if there is more positive and negative and there's more positive than negatives, then it could create a biased model. And the evaluation is like different based on like if there's more one class prediction over the other. So in here, we see that it's relatively similar actually, because like I only imported like 10,000 rows. I guess in the actual, like if I were to import like the entire data set is actually 50-50. But in the first 10,000 row is around this. So I would say that this is still like a balance for classes for labeling. So this is just a second, I think. Okay, I was just looking at some chat. So yeah, that is essentially what you should be looking at. And you can definitely do more analysis on the data, like the reviews at first, but we're not going to get into that today. So as Sammy has talked about briefly, like there is lemmatization and stemming and like stop words in terms of the preprocessing part of the natural language processing. So with like exactly like what happened with lemmatization and stemming is that you will either use one. You cannot use like the 2 of them at the same time. So a lot of the times lemmatization has like been proven to have a better performance than stemming. And the reason being that with lemmatization, you're just like reducing the words to its base form. For example, like running, runs, ran will all just go to run, and better, best will also go to good. So it is going back to like an actual dictionary form, where our stemming, I guess in here it doesn't really have the example, but sometimes the final word, because it's just removing the prefixes and suffixes. So essentially what happened is the word that it conferred to might not necessarily be a dictionary word. So in that sense, like that's why the model might not be able to understand it better, I guess. So that is in general, lemmatization is just a better choice. Also like stop words, for example, like these, the, is, in, and are not really necessary. If you were to think of a model, it's kind of unnecessary, like sometimes to include that, but it really varies with machine learning because it's a black box at the end of the day. So sometimes removing it could increase the performance, but sometimes not. So it's all down to like experimentation in the end. So in here, I have defined a preprocessing function where to start off with, I'm just going to walk through the code one by one. So in here, to start off with, you will want to like lower the text, like lowercase everything, because at least like, because we're doing more basic models here, the model itself is like very sensitive, like potentially uppercase and lowercase. So to start off with, you should like tokenize it with the text being lowercase. And tokenization is essentially just breaking down a sentence into like each separate component of words. And after like for example, instead of this whole sentence, it's going to just break down into like each word in a list form. I can show you some examples after. After that, you can like choose to remove stop words or not. And like essentially, because in the NLTK, package that we imported earlier, we pretty much can just like use their stop words, but you can also like have your customized stop words because you might just want to add more things on it. But essentially what it does is just like removing any common words in this case. And afterwards, you can just do the lemmatization where you're just using the library again. So yeah, that is pretty much the essence of it. And then in the end, you just like sort of join everything together because this is just the pre-processing part. So if you look at here, I have, say if I want to apply the pre-processing function now to the review that we just saw earlier. So previously, like you see that, for example, this is the, this is the first review, where it's like one of the other reviewers, etc. Or you can see like the fourth one where there is like capitalizations and there's like capitalizations and stuff. So essentially what happened is after the pre-processing, you see that a lot of the, like everything is lowercase, like everything is like in is tokenized form where things are separated. For example, the word like previously, this is all together, but now because of the tokenization, it recognizes like separate words. So that is essentially what is happening with the pre-processing function. Yes. So yeah, and then upon that, after pre-processing, you can like use like just split it to train and test. And I just do 80-20 where the training is 80. So after like splitting it, what you can do now is like using count factorizer. Count factorizer is a very common technique that is used in like NLP. So essentially what it does is like sort of, it's just converted to like a bag of word model. So in essence, this is how the walkthrough step is, where first we just tokenize it, and then from there we build a vocabulary. Because like with count factorizer, as you might be very familiar, like bag of word is essentially creating a vocabulary that like from all the unique words within a document. So I'm going to show you an example after to make sure everyone understand it. So onwards, you can also like do counts the word occurrence, and then from there generate the matrix from there. So that is the essence of how count factorizer works. And then from there on, you just train, like from this like sparse matrix, you can just like train the model from there, because now you have like the factor form. So yeah, so to give you a better understanding what count factorizer is, essentially, for example, if you see this 3-sentence like I love programming, Python is my favorite programming language, and programming is fun. So if you were to apply count factorizer, the vocabulary that we see, which is like the unique words in the document, is like the highlighted part of here. And what you will notice, I guess, is, for example, sentence 1 now, because I love programming is like in sentence 1. So these are marked as 1. But something you can note is sentence 3 actually has programming is fun. So because programming is like, you only will have unique words within the matrix. So programming only appears once in this whole vocabulary that it builds. So all of them just like, so you won't have repetitive like words in here. And that's why it's like sentence 3 has 1 in programming and is here, and fun being like the additional word that sentence 3 has created. So yeah, so that is essentially the idea of count factorizer. And I guess it's kind of straightforward in the sense that sklearn has provided everything for you. So essentially you just like call this function that is from sklearn. From there on, you initialize that class and just like transform the training model. So you just transform the training model, and from there on, you also transform the test sets. And you see that like in here, the vocabulary size is actually this big. So because I have done like 10K data, so like upon the 10K data, we see that there is like 43, 44K unique words. So we can get quite large depending, like as you increase the data set size, I guess there is a correlation of increasing vocabulary size. So wait, let me just run all of these really quickly. So yeah, like I imported this. Okay, so in here now, I'm going to talk about TF-IDF. So count vectorizer and TF-IDF are the common use way of computing the matrix, and then like feed it into the like the training for any models. But TF-IDF actually is more frequently used than count vectorizer because like TF-IDF essentially stands for term frequency inverse document frequency. So essentially what it actually does is that it measures how important each word across like documents. So because, for example, like in stop words like is, these words actually happen very frequent in any normal like data sets. So these words actually a lot of times are more useless than words like programming, Python. So because like Python and programming, these unique words might be more important. Count vectorizer that we show here might necessarily like ignore how important the word programming and how important programming and Python is. So that sort of leads to like a reduce in performance. So with TF-IDF, you can sort of like this evaluation is essentially like the number of times a certain word appear in a document divided by like the total number of terms in the document. And then there's like a whole formula that people just like generated, but in essence, it's just giving higher weights to important terms. So that's why it's like TF-IDF in general should lead to a better performance. So again, very similar idea. You just call the function from sklearn and then transform the data from there. So after everything, like now, because like this should be a matrix. Yeah, so this should be a matrix form, where it's like because in the train is like 8,000 row and like there is by 43K. So what happened is that you can just use this matrix and then fit into any model. And in here, I use naive Bayes, and like you plug it in and then you just do the predict, just like very normal sklearn package. Yeah. So, and then from there, you can do accuracy and get the classification report from there. So what you will see is that I did it for count vectorizer and the TF-IDF version just to make a comparison. So as you see in here, like this is the precision and recall. And I guess because, okay, so sometimes you look at precision and recall, but in this case, I would say that because the labeling is around 50-50, you can just more focus on the evaluation metric accuracy. In the case where it's like bias labeling, you can look at the other evaluation. So in here with count factorizer, you see that the accuracy is like 0.84, while the TF-IDF is slightly more by 2%. So that is just how you use like naive Bayes very quickly in terms of doing text classification. So another way you can do, like, for example, the SVM classifier, and yeah, I guess it might take a little slightly longer to train, but essentially the idea is the same, and then you can look at the evaluation. So depending on what the data is, you can choose different models and then play around with it to find the best optimal model. It's hard to say what model works the best without testing it. So the best way is just like testing things. While I was waiting, I'm just gonna scroll down. So yeah, like, I guess the coding questions that I have provided is like these two. So for coding one, like, because previously I talked about removal of stop words and lemmatization, stemming, etc. So like one of the coding question would be like, will there be an effect on the performance if we like also handle like the special characters? Say we remove like any special characters and punctuations. Do you think the evaluation is going to be the same or it's going to decrease? And the second one, the second question is like, for example, like there is parameters you can choose for count factorizer. So one way you can identify it is, so because I am using the sklearn package, so there is like a whole bunch of parameters, but specifically you can sort of choose limits the vocabulary size. So I guess the lower the vocabulary size is, the faster it computes, right? Because the matrix is lower. So in that sense, like you can play around with what happens if we set the number of like the features, the vocabularies in the count factorizers to be smaller, or instead, what if we do like n-gram? So right now it's doing each word as a new vocabulary, but what if like now we set it as like 2 words as the new vocabulary? So how would that affect the performance? So that is the two questions I have. Oh yeah, is that computing? I guess like their performance is pretty much the same. Yeah. So that is pretty much the end of my tutorial. Is there any question? I cannot see. Okay. Yeah.
Great, thanks so much. Right. So I'm gonna update the Google Colab notebook with what Sammy sent. Sammy, I think you gotta give me access. And then
Yes.
So meanwhile, like, do the participants have any questions on the material that Elaine or Sammy covered? Anyone?
You have access, everybody has access.
Right. Cool. Okay, Sammy, do you want to cover the Q&A period? Or do you want to go over the questions that you just sent, or like?
What? Yeah, sure. My pleasure.
Yeah. But
Is there-
yeah, meanwhile,
Is
thank
there
you so
any
much.
question?
Yeah. Thanks, Elaine, for covering the material. That was nice. Yeah, if there, it seems that there's no question. I don't see any raised hand. So yeah, Sammy, do you want to go over the questions that you just sent me? or-
Yeah, sure. I'm gonna share my screen.
Yeah.
Do you see my screen?
Yep.
Okay. So the first question is I don't know if you so some students have the time to check it, but it's more about knowing the method NLTK download. This is method, so this was field blank here, to field blank to download the glove embedding file. So first you had to use the NLTK download method. And then this is some very basic coding skill, like using to tokenize, to be able to tokenize a sentence with NLTK by using the word tokenize method and put the variable sentence here. So this was pretty much straightforward. So 2 field blank. The second question, it was more related to the tutorial of Saturday of Farzad. In the context of the CNN classification model, what loss function should we choose? And for a CNN-based classification model, usually we choose a cross entropy loss. So, and with the second, which optimizer we should choose also, it was an Adam optimizer that we usually choose. So this was very straightforward also, but you need to know how to, for very beginner user, how to write a cross entropy loss and how to use an Adam method and write some parameters inside. So this is second question related to Saturday's tutorial. The third question also was related to Saturday tutorial, because Hussein asked me to make some question on that. So it was also pretty straightforward, is filling some blanks and using the word embedding methods that we went through last Saturday to it. And putting hospitals, which is the word, the term that we asked you to use in this question. The fourth question is just one of the basic tasks that we usually do in NLP is to try to know the size, the vocabulary size, very important. So it's to be able to use the len method while with the word embedding that has been loaded there just before. So there is a field blank, the explanation, the field blank, and then the answer here. Okay, so it's I did not do a tricky question. It's very straightforward, since I know that many people are beginners, but if people want some more questions, I can send. I have a lot of much more complex if you want to practice. Okay.
Excellent. Thanks so much. And yeah, so that concludes the tutorial session today. So I'm going to stop recording.